Okay, fantastic. So, as most of you or everyone probably knows, this is in conjunction with Claim Academy. And one of the main things I just wanted to promote, because it's basically new, going back just a few months. We have a full stack JavaScript class, and that essentially, and we'll get into what that means, full stack JavaScript, a little bit later. But essentially, it means that you can learn one language and you can manage things on both the front end, like in the browser side of things, and on the web server side, all with one language. And that's something that's pretty unique about JavaScript. So that starts on January 11th. A little bit about me. I'm originally, my background, I graduated from Missouri S&T as a mechanical engineer in 2005. I didn't really do too much with engineering, but it really taught me how to focus on problem solving. So I would say in this industry, if you've done any kind of problem solving, you're in a really good spot. It doesn't have to be like, technical problem solving. Even if you're like in customer service or coming from a military background, there's almost anything where you go to some type of a workplace and you solve problems in a timely manner. That's one of the key things to what developers do, JavaScript or otherwise. So I've been a freelancer since 2013. Basically, just worked independently on a few projects here and there with all kinds of different clients. Did some graphic design in addition, and then really started to focus on JavaScript back around 2018. That's when I was asked to rewrite some curriculums for college in the area, Southwestern Illinois College, and started teaching there, and then got pulled into a couple of boot camps to overhaul their curriculums. And then I've been teaching the sessions with Claim I taught a couple over the summer, then we took a little bit of a break and we're starting up again January 11th. So yeah, and I mean, I just posted a couple of feedback I get from students, because this is really important to me. It's mainly the reason why I do what I do, like in terms of teaching and rewarding. And especially I'm excited about the person on the right here. This just came in yesterday. And we had a group of 5 people in our last session, and he's at least the third person that we've stayed in touch, where he just got his full-time position earlier this week. So I was super excited, especially for Daniel. So even in this kind of uncertain time, folks are coming through, putting in the work, the patience, persistence, and they're getting some results. So moving on to kind of the main attraction here, what we're here to talk about is just to pick up some fundamentals of computer science from a JavaScript perspective, of course. So a couple of things. The presentation I put together, I just kind of grabbed a few snippets from some of our early lessons that we do in the boot camp. And then I do want to emphasize that in an actual classroom, this is much more interactive. So I've got a little bit of interactive stuff today where I'll show you, we can code along with me if you'd like in a little bit. But I just wanted to make it clear that the way our classes are run is not quite like here, where today's a little bit more where I'm just sort of talking and you're kind of following along. Definitely make it more interactive, lab work, hands-on, practical stuff, a lot of Q&A. In fact, my general rule is to try not to speak for more than 90 seconds consecutively before we sort of break and do something else with it. So, all right, so without further ado, why JavaScript? Why do I promote or sell JavaScript so much? Because as I talked about earlier, it is the one language that you can learn with. You can, in a way, you can kind of do anything. It's a little bit like your Swiss Army knife, right? It's the only language, again, that can cover all the bases. So what do I mean by that? Well, in our full stack curriculum, we deal with, of course, creating web-based applications that also work well on mobile through the browser. And we do that with something called React. It's a JavaScript library that specializes, like, say you have an e-commerce website, there's a lot of things going on there. Somebody clicks add to cart, you've got to quickly update the cart, show the total, update taxes. There are all kinds of interactivity. How is all that managed so that it's quick, it's snappy, it works well? One of the popular methods for addressing all of those concerns is by using a JavaScript library such as React, which is a big part of what we teach in the boot camp. But that's just for the browser. With JavaScript, you can also write code for web servers. So what does that actually mean? Going back to like the e-commerce example, so that's all fine and good. I'm in my browser, I add to cart, I fill out my payment details or whatever. Once I click submit or place order, what happens then? It's got to go somewhere. We now have to leave the browser. So the process of transmitting that request, sending it off to a web server, that's where JavaScript Node.js comes into play. It receives that request and it's able to process that, update the inventory, do whatever it is supposed to do. And again, JavaScript is the one language that can cover both sides of that. But we're not done yet. Those two areas are the main things we cover in the boot camp. But beyond that, we can take Node, we can take JavaScript fundamentals, and we have something called Electron. With Electron, you can, again, use JavaScript to create native desktop apps. So we're no longer in the browser. We're not even talking about the web now. We're talking about you write one code base and you can make that an installable app, all for Mac, Windows, Linux. You don't write it 3 times, you write it 1 time and you're able to deploy it for anything and it's installed like an actual application. And wouldn't be complete without something like React Native or Ionic. Those are a couple of JavaScript-based frameworks where, again, you're now building native mobile apps. We're not talking about the browser. We're talking about the Apple Store and the Google Play Store, apps that you would deploy there. So again, one language, limitless possibilities. This is from a site called Stack Overflow. Every year, it's you can Google it, but it's essentially a big giant Q&A forum where all developers go to exchange ideas and ask questions. So every year they do like this developer survey, and not really too surprising. So this screenshot is from the graph where it just talks about what languages are folks working on a day-to-day basis. You know, where are they spending their time? And as you can see, JavaScript is basically everywhere. Of course, you have to have some HTML and CSS to kind of make things look nice in the browser. And then it kind of goes on from there. I should also mention that we cover TypeScript in the curriculum. And TypeScript is sort of a superset of JavaScript. So I'm not going to go into the details, but they are directly connected. JavaScript and TypeScript are, like I said, both intertwined, if you will. So JavaScript's not going anywhere. It really is the language of the web, and pretty much everything that we do is web-based a lot of times. So that's the only language that can handle that inherently. Another way to put it is Claim has always taught in their Java and C# programs JavaScript, but it's kind of like, just on the side, just the basics that you need to know to get a little bit of front-end interactivity. But that's the difference now. We created this curriculum that's a full stack curriculum now. So maybe it sounds a little bit snarky, but it's true. Java and C#, in order to be useful on the web, they need JavaScript. JavaScript doesn't need Java or C#. All right, so before we get in, we're going to do a little bit of live coding. Always, that's kind of a dangerous thing, even on simple stuff. Somehow, when we do demos with live coding, stuff kind of goes off track. But we'll give it a whirl. But I just thought, let's see if we can make this work here, just to make it a little bit more interactive. I am going to, I'm going to try to open up the chat here, and you can start putting in a few ideas. Or, like I said, put your questions in the chat too. And then I believe we have a couple people from Claim also that can maybe jump in or let me know, and I'll try to address those questions. Otherwise, we'll do Q&A at the end. But we just thought I would just show some code, some basic code, and talk about what it's doing here. So like this first line of code here, if you have any ideas or anything, feel free to drop them in the chat about what do you think this first line of code is doing there. And let me click on here. So if you have any questions while we're going through this part, let me know. But I'll kind of give you my interpretation just so we can start to think in terms of code. So we should start by understanding that everything when it comes to computers has to do with some type of data. And the most fundamental part of programming is how can I keep stuff in the data? Yes, exactly. I see a great snippet right there. Cool. I'm glad this is working. It makes it feel like I'm not just talking to myself. Thank you, Malia. Yeah, she says we're creating and defining a variable. Exactly. So if we break that down a little bit more, we have this key word called const, and you might think that means constant. And that would be a reasonable guess. Unfortunately, it's not entirely accurate, but for right now, yeah, we can just say that it's constant. So, but when we put the keyword constant, we're letting the computer know, hey, I know, computer, you have a lot of memory, and I need to reserve one of those memory spots. Okay, so go ahead and take care of that for me. And oh, by the way, let me give you a name for that memory spot. So, like num1, that's a made up name. This could be Mickey Mouse or whatever we want here. So, this is a keyword to reserve space in memory, and this is how we put a name to that. Here we have the equal sign. We're assigning an assignment operator. And then this is our data. In this case, it's just the number 3. So take the number 3, assign it to a spot in memory that we're calling num1. Okay, we'll do another quick one here. A little bit more complicated, but not too bad. So in this case, you see a keyword let. So for where we are right now, you can think of const and let as kind of the same thing. The difference is, the analogy that I give is sort of like dating and marriage. And in this scenario, we're going to pretend that there's no like divorce or separation, like marriage is marriage. Const is like marriage. What this line actually means is that the number 3 is permanently married to that memory spot num1. No one else can take 3 spot. Num1 cannot be bound to anyone else ever, as in the life of the program at least. Okay. Well, let's a little bit more like dating. Right now, we're saying, okay, this spot in memory num2. Right now, I'm going to assign it to the stuff on the right here, the 1 plus num1. But we're just dating. We're not really going to be married necessarily, or we're not going to be married because you're on let. So what that means is in the very next line of code, if I wanted to, I could say, yeah, you know what, just throw that away in the trash and let's connect num1 to something else. So that's the difference between const and let. Okay, so what we have here is the most basic math operation, just adding. Technically in JavaScript, that is concatenation. It's a little quirk in JavaScript. We won't get into that right now, but you can just think of it as adding. But we're just taking whatever the value of num1 is and adding 1 to it. So in this case, that would be 4. Great. So I'll see if anybody wants to drop something in the chat. This block down here is a little bit more involved. Anybody have any thoughts on what's going on there? I'll wait a few seconds to see if anybody wants to drop an idea there. Meanwhile, kind of start on this. So here we have a keyword while. And in here, we have what's called an expression, something that creates some type of a value. We're comparing two things here. So what this is saying here, and this is how we do it in class, really, we take our code and we just translate it sort of to human conversation as much as possible. So we say while it's true that the num2 variable has a value that's less than 10, I want you to do all this stuff in the braces. So it's another very fundamental part of programming is looping. Computers are very, very good at doing repetitive, redundant tasks without making mistakes, without getting tired. So that's what we have in this spot here is just, we're going to run this code here, console log, think of that as like printing something. So keep printing the value. And then this last line here is really, really important. If anybody has any ideas on that. What this is doing, because it looks a little weird, it's got like a double plus sign on here. This is a shorthand for incrementing the num2. So num2 was 4. We come in here, 4 is less than 10. That means we need to do this stuff here. So we'll print 4. And then this part here takes 4 and then, takes num2. Exactly, adding 1 each time the while loop runs true. Yep, very good. So whatever the value of num2 is, if it's 4, I want you to add 1 to it and replace the value. And that's why we had to use let up here. If we put const, this wouldn't work because that means num2, you can't get a new value. You're married. So, yep, printing the log of 3 to 10. Yep, you got it. So, sorry, I read that too fast. Num2 starts off as 4, so it would be 4 to 10. So we'll actually do some live coding, but that's a pretty much a really good idea. You have the idea of what the loop is doing. So creating spots in memory, working with data, running basic loops. All right, so let's look at another example here. Oops, I think I have to switch over to this tab and then hit plus here. Okay, cool. So another very fundamental concept, let me switch back to the chat so I can keep an eye on that. Very fundamental concept in any computer science is writing functions. Functions are all about action. They're all about doing things. So here we have the keyword function, pretty much the same thing as a constant, a let. It's just letting JavaScript know that I'm about to create a function and I want you to put it in memory. Oh, and here's the name that I want to use for that function. You'll notice that when we write functions, only a couple of examples here. Remember I said functions are actions, and that's how our naming should be reflected, right? So calc, like calculate something. So typically it's not required by JavaScript, but as we are going through the curriculum, I'm always wanting to show folks some of the best practices that when they join a software engineering team, just some of these good habits that'll come along and just make it, their transition a lot more seamless. So this is one of those kind of best practices. So name your functions with an action verb, indicating that it does something. So here we have one for rectangles, one for perimeters. What we have here are called parameters. So if you think about it, if I have a function and I say, hey, I want you to calculate the rectangular area, and that's all I say, well, it's not helpful. Okay, I kind of need to know the length and the width, if you don't mind. So that's what the parameters are. It's additional information that the function is going to need to do its job. And then a lot of times in functions, we see a return keyword. That means take in your input, do something with it, and just return that out. So this is how we write functions, the basic ones. And surprisingly, most of the functions that we write, I always teach that your function should basically do one thing and one thing really well. It shouldn't do 20 things. So a lot of times, even if we're building more complicated applications, our functions are usually only 1 or 2 lines long. It makes our code easier to read and allows us to embrace principles of what's known as modularity and extendability. So we're taking our code and we're breaking it up into little modules. And then we just assemble those modules to create larger applications. We don't want to have these big, heavy chunks of code if we can avoid it. So very simple functions, usually just a couple of lines. How do we use the functions? Well, we see that right here. We're saying calc rect area, and 7, the data, the number 7 becomes the len, and 11 becomes the width. So 77 is what we would see if we were to run this code. Excuse me. So same thing down here. That's how we use functions. So function keyword, actually I have a review thing on the next slide over the stuff we just did. All right, so quick rapid review. What have we seen so far? And by the way, these slides, of course, they're on a live URL. I'll be happy to share that link and you can go back through these and follow up with questions and whatnot. So we have rapid review. We had a keyword const, variable name given here, an assignment operator equals, and the data type was a number. And this is binding data to a variable. What else did we, we saw basically the same things here. Keyword was let, variable name was num2, assignment operator was equals, data type was a number. We have a concatenation operator, just think of it as an addition operator, that's fine. And we're going to add 1 to the value bound to num1 and assign that to num2 or number 2. Okay, and then we saw the while loop. Keyword was while. The stuff in parentheses was our expression. We had a comparison operator, the less than sign. I didn't mention this earlier, but I said it was going to be while true. So true and false, those are Boolean data types. That's the name Boolean. These are things that are basically in every programming language. So anything that's true, false is a Boolean. So while this is true, do a bunch of stuff here. Basically, when we take keywords, expressions, like we have here, we're forming a complete statement. So while it's true that the value bound to I should say num2 actually, while num2 is less than 10, do this stuff in here. And this is saying keep replacing the value of num2 by adding 1 to the current value. So the previous value, kind of just a bit of trivia, it's garbage collected. Like that's what they actually call it. It's just kind of hanging around in memory. Num2 just broke up with it and took on a new value. So anything kind of left over is literally thrown away, and JavaScript just scrapes memory. It's called garbage collection. All right. So that's some of the basic things that we have there. Let's do a couple of live coding examples then. If you'd like to follow along, let me just show you how I got here. So the easiest way, so like when we do the class, we actually set up all our computers on like day one with a complete developer environment and everything else. But a quick way to, if you want to follow along, totally up to you. You can go to the site here. Let me drop this in the chat. It's called REPL or Replit, repl.it. Let me drop this in the chat here. Oops, repl.it. So you can go there, and once you get to that screen, you're going to want to select node.js. You can click this plus sign in the top right, and you can select node.js, and then you can make up a name, or they just give you random names. So and once you click create REPL, you'll have something like I have here. Yours might be formatted a little bit differently. There's some settings, but I'll give everybody a couple of minutes there. And in the meanwhile, if you want, we can do just a quick mini Q&A if you'd like, about for a minute or two before we do a little bit of live coding. So anybody have any burning questions while we're getting over to Replit? Again, you can just watch this and do this, follow later, or you can try to type. So any questions? I'm going to get a drink while you're thinking about that. Yeah, so in the class sessions, so what I try to do is we kind of just hit it for 20, 25 minutes. Concatenation is for literals. Yeah, actually, let me show you why I called it concatenation as opposed to addition. So we'll actually, I'll just put that up here in just a second. Good question there. But yeah, in the class, I always emphasize we kind of do like, there's about 25 minutes. We'll kind of hit these concepts, review, maybe do a quick mini quiz. And then I always encourage everyone to kind of get up and move around for like 4 or 5 minutes. It's kind of our pace in the class. So, but let's see, do you think it's better to learn CS fundamentals? Okay. So let me actually read the whole thing. Do you think it's better to learn CS fundamentals before learning to code? Have you seen students learn coding through doing and then pick up CS fundamentals later? So I'm trying to do, that's sort of what I'm trying to do here, is a little bit of a hybrid. So there are like some, online things and stuff like that, where they literally just give you a lot of slides and they talk about, like a loop and functions and things like that. So I feel like that's kind of what we're doing here, a little bit of a hybrid of hands-on while picking up fundamentals. So of course, we're not here building an e-commerce platform or anything like that just yet, but believe it or not, it's a 12-week program. And by week 9 or week 10, we start off here like in week 1, and around week 10, it's definitely not impossible for someone to have all of the fundamentals down well enough to build a simple e-commerce platform. So that's kind of like the pace. So I would say that, no, I'm not sure that you really need to everybody has different learning styles. So I like to keep it a little bit more hands-on as much as possible rather than just kind of textbook CS principles. So, but yeah, keep the questions coming. Let's take a look at this concatenation thing. This is a little bit of an embarrassing thing and for JavaScript. I don't like to show this part. There are a few quirks in JavaScript. Of course, I kind of gave you the sales pitch early on, made it sound like JavaScript is just magic, but it's not perfect, just like anything. So if I have a couple of things in here, let's say, let's just create a variable, like just say const x equals the number 3, const y equals the number 4. If you're wondering about let versus const, the general guideline is just use const. And here's why. Let me just show you what happened. So I said const. So what that means is I cannot go over here and say x equals 5. If I run this code now, it's going to say assignment to constant variable. Now, that is a bit of a misnomer, though. I'm going to show you in a little bit why it's not really a constant. When we're talking about numbers and strings and things like that, yeah, it's a constant. So we start off by calling it constant. So that part I wish it's kind of misleading, but so that's what const is. If I was to say let, switch that to let, then that's not a problem. Our code runs and we see 5 over here because X and 3 are just dating. They're not married. So X can drop 3 literally in the trash and go date 5. Okay. And then after that, not only that, but next, X can say, yeah, I don't even want to date numbers anymore. Now I'm going to date strings. So anything we see in quotations like that, that's literal strings there. So that brings me to, I believe, hopefully this is what Nick was asking about. So I can say, for example, let me take out the string part here. I can say x plus y, and as we can guess, that's going to say 9, 5 plus 4, okay? Now, the weird thing is, if I mess up, and let's say I put quotations around the 4, now it's no longer a number, it's actually a string. And that's why we call it concatenation, because if I leave the rest of the code alone, it doesn't say 9, it ends up saying 54. And I don't know how you enlarge it on this side, but it's shown in white here, indicating that it's a string. So what happens is if we have a string and we add it to a number, JavaScript comes in and says, oh, this isn't really addition, this is concatenation. So what I'm going to do is just make everything a string. So what ends up happening is we are essentially looking at the string 5 plus the string 4. So anytime there is a concatenation operator and a string involved, everybody else is going to be turned into a string. And that's I've never had a need, and I'll show you why. There's really not a benefit to that. And I really wish it was just, look, this is addition and not like, oh, I'm going to try to turn everything into a string and be the concatenation operator. So hopefully, Nick, that was at least close to it. If not, you can follow up with another question. But that's why we say concatenation, because literally I can take the string 5, I can take the number 4, and I can concatenate it with the Boolean true. So this is a Boolean because there's no quotations around it. And when I run that, I'm going to see 54 true. So it just turns everything into a string. And that's why I call it concatenation and not addition. I would say 98% of the time, what we mean is addition, but we have to be aware of a couple of those gotchas. All right, so that's, gives us a little breakdown of a few of those. Let's write just a couple of simple things here, and then we're going to cover a little bit more about data concepts. So let's see, I had a note for myself here. What was it? Okay, we're going to write a function. Let me see if I can just copy and paste this here. All right, so here's kind of like you can get a start on this. So we want to write a function that takes in an age and returns a Boolean that tells us whether somebody is an adult or not. Basically, if their age is over 18, it just kind of checks their age. So how would we do that? Well, like we saw in the slides, we want to use the keyword function, saying I want to reserve some memory, and this is something that's going to do something. Since this is an action, it's nice to start our name with a verb. So for example, check is adult, something like that. So this is going to take in an age. So now we've said that, okay, for this function to do its job, it's going to need a parameter. We're going to call that age, but we could call that anything that we wanted to. But of course, it makes sense to do things that make sense. So we can see this is a function. It does something. And just by reading this, it's pretty clear how this is already starting to work. Now we need some braces to establish our scope. This is where we put the code for the function. Now, how can we check to see if someone is over 18 or not? We're going to need to do that comparison that we saw earlier. So we're going to be something like if age, we could actually say age is greater than or equal to, greater than or equal to 18. But we need to do some sort of if logic. So here's a keyword if. Wrap this in parentheses and throw some more braces up. So one sort of downside about JavaScript is that there are going to be a lot of braces and parentheses, and sometimes it can be frustrating that your code is all pretty much there, but you're just missing a parenthesis somewhere. The good news is part of the tooling that we set up on day one, I have automated a lot of that stuff. So it really allows folks to just get in on their, we work with VS Code, and we have it configured, pre-configured in a really productive way so that students aren't wasting their time chasing down I mean, not as much. You're still going to chase down parentheses once in a while, but not quite as much. So here we can see if age is greater than or equal to 18, how do we terminate our functions? Use that return keyword, return, and then we just said, oh, returns a Boolean. So we could return a string that says is an adult, or I can just say true, return true. And then down here, I'll show you sort of the long way, and then we'll trim it up. Then I can say else return false. Let's just try that now and see how it's going to work. So we'll say check is adult, the name of the function. We'll invoke that function with some parentheses, and we'll pass in a number like 23. So the expectation is that 23 will go into age, and it's going to be, this is going to hit true, so it's going to return true. Okay, so if we run that, we do in fact see true log on that side. I really don't, I said return a Boolean. I guess we could, like I said, just to show, we could also return a string like is adult. So if I run this now, I see in white on this side is adult. All right, so let's run it the other way. Let's give it the age of 2, and now it should say, we can just switch this to is minor. We could do true or false, but is minor and is adult, maybe more clear. So we see is minor on this side here, okay? So everything is working, and so that function is good to go. There is something we can do to shorten this function though. You see, as soon as we hit the return keyword, return will immediately terminate a function. So what that means is I really don't need this else, because as soon as this return hits, it's over. So there's no need for this else. I can actually remove this, and anytime we can remove some braces, it's a good thing. And this will still work just as expected. What's going to happen with the number 2? It's going to say if the number 2 is greater than or equal to 18. Oh, it's not. Okay. So it's going to skip that, and it's going to come over here to return is minor. So everything works just fine. So what I'll do now is I'll just give this a little name, like maybe age checker. Okay. And I will go ahead and share this. I'll just dump this in the chat here so you can have this code. Copy REPL link. I'm going to dump this right here. Okay, so just in that little bit, it says fail to connect. So I don't know. Now it says connected. Just in that little bit. Oh, I forgot about this. There's like multiplayer. Maybe on some other time or another demo, we'll try to do where everybody's coding something together. That'd be cool. We do some of that in the class. Anyway, just in the little bit, like in whatever, 20, 30 minutes, we've hit quite a few of the basic fundamental concepts that apply to any language, creating pieces of data, function, keywords, if, while, things like that. I see it's already 3:40, so I had another one we were going to do, but given the time, I'm going to move forward and go over a few more concepts that are definitely pretty critical. So we've only seen like basic data. What about collections of data? Oh, this was just the review about the functions we just saw. So, okay. So we just did that. So we talk about things called arrays. Arrays are also pretty prevalent in any programming language, but an array, actually, I think I have it on the next slide, it's a list of other data types. So they can hold any other data types. We reference elements in an array using an index. Okay, well, you can read that. Let me pull up just an example. So I just call this grocery list. We create an array with brackets. So there's some brackets. And in here, I have some strings, and I have just this weird number 1. I also have an empty set of braces. We haven't talked about what that means yet. Hopefully, we'll be able to mention that before we're finished. So the grocery, I mean, realistically, the grocery list probably should just be all strings. Just wanted to emphasize that, hey, you can, in fact, throw whatever you want in there. All right. And then how do we act? It looks like my image is broken here, but if we wanted to access the first item, we're going to say grocery list 0, bracket 0, and that's going to show us apples, actually. So in an array, we've just learned that the first item is actually index 0. Let's see what else here. Let's add a couple of broken images. We already did functions, so that's kind of weird. Okay, well, I think that was all. Okay, here, I want to come back to object literals. Let's play with arrays, though. So I'm going to click here in Replit, and I'm going to say, actually, I'll just create a new Replit, + Node.js. This one will be array example. I'm going to do a couple of quick things with arrays. Again, I want to emphasize that we do kind of catch our breaths in the class, and we do a lot more Q&A. So if you feel like this is like, going fast, that's okay, because it's like we definitely take the time to deep dive a lot more. All right, so font size large, great. So let's create a quick array here. I'll just pick a couple of names that I see listed. Okay. And oops, make these all strings. Oops. And if I forgot the quotations, you'll see that that's going to create an error. So if I run this, it's going to say unexpected identifier, because over here for Joe G, it needs to be wrapped in quotation. So that's a kind of a common mistake when folks are just starting out. Any words always need to be in quotations. You can see the rest of this, though: keyword const, variable name, assignment operator, and brackets. Okay. So really quickly here, I want to leave a little bit of time for questions or any other Q&A discussion. Let's just write a quick program that will just add something to everybody's name and then output the results. And we can do that with a simple while loop. So let's do that at this time. I'm going to, well, actually, before I do that, let's do this a little bit of the long way. I'm going to say students bracket 0. I'm going to use concatenation here, actually. And if I run that, it says, well, I'll put a space in here. It says Rebecca space hi, or I'll make this a little bit more sensical. Rebecca says hi. Now, you may have noticed here, if I want to use quotation marks inside of the string, all I need to do is use single quotes inside of my double quotes. So now it says Rebecca, oh, I need another space here. By the way, there is a much better way to put strings together. Like I mentioned earlier, we don't usually use the concatenation operator. It's just what we're doing now. So it says Rebecca says hi. Great. So if I wanted everybody to do that, one way I could do that is just by copying and pasting and then switching student 1, student 2, student 3. And that would get, well, you're only seeing the last line of output. So it says Joe G says hi. Okay, this is the way Replit works. It just shows you the last line unless you put console logs around stuff. So, this is one way I could do it. Obviously, that's not very cool. I'm not gonna, what if I have 100 students and we have to do more important stuff than just saying hi? That's not going to cut it. We can use a while loop to simplify our lives. I'm going to leave that code on the screen. And let's just see where it says 0, 1, 2, 3. That's known as an index. Well, let's create a variable. We're going to use let, because that's going to need to change. Index can't get married to one number. It's got to keep swapping out numbers. So let index We're going to say start at 0. And then we're going to say while index, I'll explain what this is in just a second here. I'm going to set this while loop up. Okay, so the strategy here is we're going to run this. Oh, and the most important part, index plus plus. What would happen if I forgot index plus plus? Or in this case, for any while loop, we would have an infinite loop. It would never be able to exit. It would keep coming back around, and index would always be 0, and it's always going to run this loop infinitely. So a couple of things are happening here. Like I said, I'm just trying to show the example in the remaining time. So students.length, as you can maybe guess, actually, I can just I'm going to console.log students.length. If I hit run here, it says 4, and that's because the length of this is 1, 2, 3, 4. So it's a little bit, I would say, oh, you were asking, I would say hi, repeat. Yeah, well, we haven't gotten to that part yet, but yeah, let me just show that part. If I said console.log students bracket index, and I did not have this in here, you're exactly right. I'm not going to run it because I think Replit will crash out and I'll have to come back in and all kinds of stuff. So yeah, very good there, Rebecca. You're exactly right. If it was an infinite loop, index would be 0, and it would, oh, and I didn't do the say hi, but it definitely sounds like you get the point. So I'll say says single quotes hi. There we go. Okay. So we ran this now. Rebecca would just say hi repeatedly. And in this case, we need to say index plus plus. So let me just run that here, and we can see that it gives us an error, and that's because I messed up some quotation marks there. There we go. Let's try that. It says, and let me get rid of this other. So we get the desired result, as you can hopefully see on the right side here. Everybody says hi right there. Okay. And so you probably figured it out now. Students.length means keep running this until we get to the length. And you'll also notice that the length is 4, but the indices are 0, 1, 2, and 3. So the last element is always 1 less than the length. So what would happen if we messed up and said less than or equal to here? Nothing too crazy. It's just going to say undefined says hi. So if you access something in an array that doesn't exist, you're going to get back the special data type called undefined. For example, I could say console.log. I could say students bracket 9, some ridiculously high number, and JavaScript will not complain. It's just going to say, oh yeah, it's just it's actually in gray here, but it says undefined. So you can see here that we can make up any number that we want, and JavaScript's still going to try to work with us. So that's a good thing, but it's also kind of a bad thing. We have to really understand little nuances about JavaScript, because JavaScript, like I said, it really does its best. If you want to add a Boolean and a string and a number, JavaScript, yeah, that's cool. Let's just put them all together and make them a string, right? So JavaScript is kind of, in one way, it's very easy to get into, but it's also very easy to write sort of bad, error-prone code. So let me check on the time here. Okay, cool. We still have a few minutes. So now you see how we can iterate over an entire loop. So we do a heck of a lot with arrays because it's just so common to have an array, more specifically an array of objects. So I do want to show you JavaScript objects before we wrap up here. Let me share this one though. Click share, copy REPL link. And there we go. Okay, so we have a couple of examples, and I'm going to click the plus sign, click node. This one will be object literals. So there's a few different types of collections or lists that we can do in JavaScript, but arrays and objects are the main ones. So we saw an array. What if I wanted to make something that described a person? One way I could do that with an array is something like this. I could say, okay, I'm going to create an array that's all me, and I'm going to put my name in the first slot, and I'm going to put, I don't know, like my I say number of kids in the second spot and number of vehicles in the third spot, something like that. Okay. And this could go on and on here or whatever. So we can see, actually, I'll just put one more. I'll just say the year that I graduated college, 2005. So now we have this sort of collection of things that are related to me. And we could do this so if I wanted to know, okay, what was the name again? Unfortunately, I would have to remember, oh yeah, the name is in the first slot. What was in the third slot again? It's not a very good way to manage data. It's fine in some cases when we just have kind of a list and we don't really care about the order. We just have some sort of collection. But there's got to be a better way to do this, and that is known as an object, more specifically an object literal. And the way that works is, I'll kind of just manipulate this to show it. We actually use braces. Yes, more braces. Braces have all kinds of things in JavaScript. You can see a lot of red marks here. Let me show you the finished here, and I think you'll get the general idea. Right? So this is what an object literal looks like. It describes one thing, and that one thing has certain properties and values. That's what we see here. So there's a name, kids, cars, graduated, whatever else. So as you can imagine, as we have maybe bigger collections of data with lots of different properties to describe something, this is going to be much more effective than trying to remember what numerical index things are. So the way that this works is this is also indexed, similar to an array. However, the indices are not numbers, but they're actually strings: name, kids, cars, graduated. Now you may be wondering, wait a minute, I thought you said strings had to have quotations. And yeah, you can go in here and put quotations in here, but you don't have to. The reason why is because JavaScript knows that if you're dealing with an object, all of those keys have to be strings. So it's sort of optional in that case. So now how do we access things inside of this object? We have a couple of ways. Probably the most direct is to use dot notation. I simply say me.name, and I see the name Manav printed right there. And if similarly, if I say me.graduated and I hit run, I'm going to see 2005 as a number coming over here. So the values can be any data type. The actual indices have to be strings, but we don't have to put the quotations on them. Here's the part where we show why, I could have shown this on arrays too, why const isn't really constant. And I'll show that right now. Const me, I'm going to change my name to Mark. And let's see me.name right here. Code runs, actually, oh, sorry, I messed that up. Code does not run like that. I meant to say me.name equals Mark. I'll actually show the other thing. So that code just runs fine, and now the name has been changed to Mark. So the trick here is to understand that with primitive data, like simple stuff like Booleans, numbers, strings, const really means constant. In this case, me is married to this object. The difference is the stuff inside of the object is allowed to change or mutate. So that's why const doesn't really mean constant. And the same thing applies to arrays. Even if it's const array grocery list or something, I can go in and reassign the value that's at one of those indices. So const, I don't have to use let, I can still use const. What I am not allowed to do, though, as you saw the error, I cannot take me and make a whole new I cannot do this. If I run this code, it will yell at me. Assignment to constant variable. So the trick is we're not allowed to use the assignment operator with the variable directly, but we can use the assignment operator with the stuff inside of the object. Okay, and with that, it's like 3:54. I'm going to take a quick drink. So I guess I didn't make a final review slide or whatever, but just in the little bit of time, we're able to see, quite a few different things. The keyword if, why, how to write loops, how to run over an array and put everything and show everything that's in an array, how to work with objects, a whole lot of different stuff. So even if you got just say 2 or 3 things out of this, then that's a great thing. Let me share this code snippet. Let me take a drink. And I do have another session I have to jump on right at 4. So we have about 5 minutes for any Q&A and things like that. Let me, I wasn't able to. Oh yeah, I haven't posted the slides yet. No, I need. Let me do that also while I'm doing this. Yep. I need to pull up the link myself. So I will do that in just a second. All right, let's share this. And we're going to dump this in here. So this is object literal. So there's 3 examples. Cool. So while you're thinking about questions or anything like that, let me see if I can get us to, yeah, I'm going to pull this up on my other screen so I can pull up that direct link. So yeah, go ahead and let me know of any questions that you have. And in about, I don't know, 20 seconds, I'll have that link here. Okay, let's see here. Make sure this is the right one. It is. Okay, so here we go. Here comes the link. You can go through those slides. So you just keep hitting, it doesn't matter. You can click through or you can hit just tap the right arrow. Pretty simple. By the way, the slides themselves, those were made using React and a special tool that works with React to generate slides called Spectacle. So, because I really don't like making slides, like, just all the clicking and dragging and stuff like that. So when I found this, I'm like, oh, cool. So I can basically kind of code up my slides, very nice. In fact, let me just share, if you want to see the code for those slides. It's a little bit of a specialized code. It's not just JavaScript. Let me see if I can pull that up also. Let's come over here. Here we go. So you can actually go to GitHub and you can go to Claim Academy JS and you can actually see some of the code that we had written. It's been a few months, so this code is just kind of stale. And for the next, I'm always making new examples and new whatever. But yeah, here's a few examples. I think, let's see, we can, so we have just a couple minutes. Yeah, we actually made a concentration card game. I don't know if that one's live yet, but you can see the code here. This is a full stack app with the client and the server. And what's that? I'm not going to even open. I'll start going into all the details and I'll miss my next meeting. So let me just see if I can. So that was kind of a fun one. I had never actually made anything with cards before, like playing cards. So this was kind of new to me. We kind of learned, at that point, everybody had a lot of fundamentals down. So we were just kind of playing around to see what we could make. So I'll see if I can find that one. It's probably called concentration. Let's see if I can find that. Yeah, it's MERN. So in case you're wondering, what does MERN stand for? That's the tech stack that we really focus on. It's MongoDB for our databases, Express, which is server-side framework that works on top of Node. And that's in charge of, if somebody comes to blah, blah, blah.com /users/create. So that comes into Express, and Express is like, oh, so this request, this person is trying to create a new user. That means I'm expecting to receive some data with their login name. So that's what Express kind of does. R is for React and N is for Node. So Node and Express kind of go together. So let me just grab this link. I think it's, yeah. I haven't, this code, I believe the code should still be working. I just know we haven't done anything for a while. Yeah, so that was one of the little card game, but it is a full stack card game. Now the part, I'm not sure if I still have that database running. So if you were to play the game and then it asks you to record your score or something, some of the parts may not work still. We made that, like I said, well, about 4 months ago. So I think the database, I probably turned that off. So there's probably no database connection. So anyway, we just have a couple of minutes left. Let's see, I guess, let me just share another link. And let me put this in perspective. This stuff that you're seeing that we built, this is just what we built in the class. The student demo day projects are far and above these. These are kind of simplistic things just for me to teach my lessons. Like this concentration game. Yeah, it's whatever. It's has a lot of concepts in it, but the demo day projects that were put out for, like I said, just out of the most recent group of 5, just already 3 of them in the last month or two, at least 3 of them that I know of have gotten positions. So they take what I taught them and really built on top of it. Because I like to say, I'm not trying to it's not a thing about memorization. If I teach people the fundamental JavaScript concepts, then they can go and research and learn as much as they want to on their own. So let me see if I can share one other one. Okay, let's look for sites.
No question, but I wanted to say thanks
yeah.
before I went. That was a great lesson. I've been a professional dev for many years at this point, but I always like to see how it's being taught. And I thought
cool.
the transition from arrays to objects was really good. To trying to remember the right index as a beginner motivation is really good.
Right. Are you in JavaScript, or are you all different languages?
All different languages, yeah.
Okay,
yeah.
cool.
Python was my jam for a number of years, but
is it? It's been if you remember on the slides, Python was, I think, right on the list there, and unfortunately, I haven't gotten to go really in depth with Python to where I'd feel qualified to teach it. But hey, if you maybe want to teach some Python, we may be reaching out to you later on at some point.
No, it's good. I like it. Actually, I did have a question about when you.
Yeah.
Well, we're a little bit over. I don't want to keep you, but
no, I told him I might be 5-10 minutes late. And so it's all virtual, so I'll just switch meetings. So go ahead.
You went with the while loops for control flow. Do you find it easier to introduce that with the indices versus a let student of students kind of?
Oh, I actually don't ever use, we go, because there's so many ways to do it, as you probably know, in JavaScript. So I don't try to cover every single one. I don't even go over the for in or for of. We start with while, that we're okay, let's use a for loop. That way we don't have to keep the separate index counter. So that's our next iteration.
Oh,
and by that time, we've covered functions. We've learned that functions can be passed into other functions. And so we're kind of jumping back and forth. So at that point, we're okay, well, here's actually the cleanest way. Or the next step is the for each with a callback function. And then after that, of course, the cream of the crop is to do our map, filter, reduce. And that's kind of where we take it. So we kind of bypass the for of and for in generally, because again, I want to be mindful of our time frame and give the stuff that's going to ultimately do that. But yeah, but I know some people like for of. I see it in a lot of examples.
No, that's good. That's good. I just find it interesting that you have the whole sort of arc, starting with learning how the indices work and then moving on from there. That's pretty cool.
Yeah, and I'm glad. See, I always say, should I say indices or indexes? I don't really know, so I always say indices. So I'm glad you say that too. So, so you
right. And is it GIF or GIF? Really, that's the
I always question. What do I think I say GIF. Yeah, GIF. So cool.
Awesome.
Fortran.
Well, great job.
Oh, I see a message from Rebecca about Fortran. As you saw in the first slide, I'm an engineering major. So yeah, that was actually Fortran was, for whatever reason, I was this class sucks. I'm not interested in programming. How can I just get through this class as quickly as possible? In all honesty, in the dorms, there were several comp sci majors, and in all honesty, I had them write some of my programs for me. So again, not proud of that, but that was, many years ago. But for whatever reason, I guess because it was Fortran, I was this is stupid. I don't want to know how to do this. But then I ended up kind of around 2010, I was trying to start a business. And I was well, I'm going to need a website. So maybe so I had a motivation to learn it because I didn't want to spend, $5,000 with somebody to create a site for me. But along the way, it's oh, Oh, creating websites is pretty cool. I don't even care about the business. Let me just do this. So that's kind of how I ended up there. So, all right, but yeah, I do have to run. So yeah, definitely. I think Kyle is on here, and if you have any other questions about Claim Academy, so I hope to see maybe some of you in our January 11th class. So with that, thank you all very much. So all right.